Okay, now let's solve a problem. 298. The cable attached to the tractor at B exerts a force of 3,500 newtons on the framework. Express this force as a Cartesian vector. Now, the point is this. We have a tractor located at B. Okay. And there exists a cable. This cable is attached to a frame, a truss system at point A, and pulls it. It is fixed at the origin. So the X, Y, and Z coordinates are given to us. So the position of A is known, okay, and the position of B is known. The angle between the point B and the y-axis is given. So we can also calculate the angle between the x-axis and B. Certainly we can define the position vector of point B and point A. Now, therefore, what we need to do is we need to find the unit vector from A to B. Then multiply the magnitude of the force F with this unit vector. Okay, so let's see. So RA is equal to, let's write the position vectors first. RA is equal to 10.5 J vector, right? And RB is equal to 15 multiplied by sine 20 I vector plus 15 multiplied by cosine 20 J vector. So these are the position vectors. Okay. So we can write this RB. So 15 times sine 20 gives us 5.13 I vector, and 15 times cosine 20 gives us 14.1 J vector. Now what we need to do is to calculate the RAB. So the relative position of B with respect to A first. So this is RB minus RA. Okay. So if I do the calculation, what I'm going to get is, sorry, this is not 10.5 J, this is K. Huh? I made a mistake. This is K vector because array is in Z direction. Okay, so RBA is equal to 5.13 I vector plus 14.1 J vector minus 10.5 K vector. Okay, now let me calculate the magnitude of this vector, RAB. It is equal to the square root of the squares of the components. So I have 5.13 square plus 14.1 square plus minus 10.5 square and square root of it. Therefore, the magnitude of RAB is 18.31. Okay, now let me calculate the unit vector from A to B. That's equal to RAB divided by RAB So the component of the unit vector is 0.28 I vector plus 0.77 J vector minus 0.573 K vector. Now this is my unit vector from A to B. Now what I'm going to do is to find the force vector in Cartesian coordinates. So this is equal to F multiplied by UAB. Therefore, F is, in this case, $3,500. Multiplied by the unit vector to 0.28 I, 0.77 J minus 0.573 K vector. Now next step is to make the operation. So what we have is $980.612 I vector minus not minus, plus 2,695.25 J vector minus 2007.1 K vector, and the unit is newtons.